Live streaming on YouTube from the largest industrial show in the Western Hemisphere and the longest running industrial show in the Western Hemisphere. My name is Matt Kirkner. This is the Tech Ed Podcast. We have been live all week from the SmartForce Student Summit, and we've been telling you all week that that summit is powered by AMT. Some of you may have wondered, what is AMT? Well, we are going to find out all about AMT this morning because we have the president of the Association for Manufacturing Technology, Mr. Doug Woods, with us here on the Tech Ed Podcast. Doug, thanks for coming on.
Hey, Mac. This is so exciting to be here. This is the coolest thing going on. I mean, overall, IMTS, but I'm talking also the Student Summit. This is rockin' cool down here.
Yeah, we were chatting yesterday with Greg Jones, your partner in crime here, and he's got over, I think, almost 12,000 people that he's expecting, 12,000 students coming through the SmartForce Student Summit. It's just been crazy all week. Kids stopping by, looking through into the studio, checking out what's going on, learning all about amazing careers in advanced manufacturing. I know that is something that is really, really near and dear to your heart and really near and dear to the hearts of everybody at AMT. So for our audience, AMT you're running the entire IMTS, is that right?
Yeah, so we've been obviously doing this from the beginning. So since the 1920s and 30s when we started putting out shows.
Amazing.
We've been doing it. And yeah, AMT, we do a lot of different things. And so this happens to be the biggest thing where everyone kind of notices us.
Right.
But our job is really overall, the United States, making sure manufacturing technology gets in the hands of people that want to use it. So making sure the latest in technology is available for people so that they can have networking opportunities. We can work on advocacy to get people in government to understand what's going on in our space, to put international tech centers around the world so we have ways for our folks to get into new markets. So we touch the industry in a lot of ways, but we're all about manufacturing technology in the United States.
Sounds like it, and all about manufacturing technology here at IMTS. I'll tell you, it's been fascinating to listen to all of our guests, all of the new technologies. We've had a tremendous number of people from the Manufacturing USA Institutes talking about advancements in materials, advancements in CNC. Had somebody talking yesterday about how they're literally fabricating human tissue. And so manufacturing has come a long, long way. We think about CNC and subtractive manufacturing. We've got additive here, a whole pavilion dedicated to additive manufacturing here at IMTS. So as you walk around and as you learn a little bit more about these advancements in technology, what are some of the things that you're seeing in your time here at IMTS, Doug, this year that maybe we didn't see 4 years ago?
Yeah, I think what we see more and more of is the pervasiveness of automation. So automation's been around, but I think the issue is it's actually getting more kind of in the fabric of every shop because sensors are lower cost, the ability to put communication on these devices between different devices with things like MT Connect, so there's open standards so that they can communicate. But you just see a lot more automation being integrated. A lot of that is because it's hard to get enough people into the industry.
Right.
But also there's some things you really don't want a talented person doing. And if a robot could do some basic loading and you can have that bright young person doing something else, designing some new tooling systems to be able to do programming, to be able to kind of use some AI machine learning to actually make it more iteratively, operation high performance with that technology. All those things really are a big part of making a difference. So you see a lot more automation when you walk around. Additive Pavilion. The Additive Pavilion, when we first started it back in 2012, I think we had eight companies in it. Yeah, we've got 68 companies
it's crazy.
now. So yeah, so the additive, and you're seeing hybrid in a lot of the booths. So people are doing combination of additive with subtractive together. So I think those two things are the biggest things you first see. Impact on automation, additive technology coming out. But also I think what's really interesting is this bringing the technology to the show. There's some question is what will happen with shows? What will happen if people want to come out and see these things and touch these things? And this show has been, 2018 was the biggest one we've ever had.
Right.
This might be the most electricity, the most impact, the most velocity of people wanting the technology and equipment. So there's just something neat about what's happening here in 2022.
Without question, and I was here in 2018, I was here in 2016, and you're right, there's an energy, and I don't know if it's just that people were, so cooped up with the pandemic, and it's just so much fun to be back in front of people, and I've seen people this week that literally haven't seen in 3 or 4 years because we haven't been together. So there's that energy that goes with that. There's the energy that goes with the new technologies, and as I mentioned, we've been talking about that all week, walking through the additive, spending some time yesterday with Juan Mario Gomez from Exact Metal. He was a guest with us talking all about the new advancements in metal 3D printing. We had LaVille Technology kicked us off on Monday morning, and they've got, to your point, a combination CNC machine, and a 3D printer. So,
Yeah.
when we were here back in 2012, and I was still in my manufacturing days in those days, and nobody had any idea what was coming from a 3D printing standpoint. And you heard a lot of machining companies, machine tool builders, controls companies saying, either saying that, there isn't anything to 3D printing, or worried that it was going to replace subtractive manufacturing. And in truth, the two complement each other really well, don't they?
Matt, great point. I mean, that's absolutely the case. I mean, at one point it was, either it's like a toy kind of thing, it's really not that big a deal, or it's, it's going to take over the world, there's going to be no machining systems. I mean, neither one is even close to the truth. One of the biggest things it does is it actually creates an entirely new way for people to think about how to design parts.
Right.
And again, back to this whole thing of all these great kids you see walking around here, they there's no boundary to what they can use their imagination to create a part, because you can do it now with additive technology. The other thing is you need the two together. There is no finished part of any production quality that comes off an additive machine you can use as is.
Right.
There's typically a process you need to do it, so you can actually now start with parts that have less material to be removed, use less energy than doing the machining, less waste.
Right.
And so overall, that combination together creates the most optimal way to actually create the part at the end of the day when they work together.
Right, absolutely. And one of the things I love about spending time with you, Doug, is that you're president of this huge organization, right? And a lot of times somebody in a role like that, they're responsible for logistics, for execution, for strategy. You really know these technologies inside and out, which is really impressive to your credit.
Like you, haven't been able to play with it in a career and running businesses for a lot of years before you come and do your next thing. It really helps kind of get you grounded in what's first, what's second, what's third, how do they all go together?
Absolutely. And one of the things that's bringing all those together is this whole idea of digitization, and I know you're watching that as well. We had Mike Chico on yesterday, the president of FANUC America, with us, and I asked him what was the most impressive thing or most interesting thing you'd seen at IMTS, and he pointed to just all the digitization, the digital twins. I want to point to a quote from one of your colleagues. It's the Chief Experience Officer, which is a pretty cool job in and of itself. Peter Eelman, am I saying his last name right?
And I would just to interrupt you on that before you
Please.
go on that. He actually, when he came to my office and we're just putting some of those C-level positions in place, because
Right.
we were giving room for some VPs to come up the ladder. So Peter comes in and he was running exhibitions.
Okay. Yep.
So his first request when he came in, he goes, well, he wants to be chief of something. He runs exhibitions. So he asked, would it be okay if I was the CEO?
Oh, there you go.
I was
right.
like, hey, dude,
Right.
kind of leave that one around for me, would you? At the end of the day, how about we find something else for you? So
Yep.
we got him over to CXO, so he could be the exhibitions guy with the X.
That's a really, really cool title. And Peter's all about all this technology. The quote that we picked up from Peter was, if OEMs and job shops can digitize it, they should. So that, and really when you think about digitization, digital twins and so on, couldn't agree more with Peter. It's an absolutely brilliant point. But why do you think that is? Why should OEMs and job shops be digitizing their manufacturing processes?
Well, it starts as simple as you think about where we first started doing that. So we started with CAD.
Right.
So we're putting everything on blueprints. Someone's got to sit there in front of a board and try to draw all that stuff out, when a lot of the geometry and other stuff you can get from a computer. So we went to bringing digital to CAD and drawing. And then if you got it in CAD and you got the drawing, well, could we then just take the drawing and give it to the machine? Now, if you had to start with that drawing and then fat finger everything into the machine, well, that seems silly. So
Right.
then what do? You made CAM, so you could bring that forward. You can then just see every extension of that going along continues to just make a lot of sense then. So now what we want to do, figure out processing, optimizing processing, actually then passing information out of the metrology system,
Right.
doing the automation with the tooling, what happens with the tooling. Have all that information always connected that way. And now we're taking it to the furthest extreme where we've made almost everything in the chain digitally talk to one another in some way. Now we're saying, can we make the entire chain digital, which is where you get to digital twin.
Right.
Could I truly get the correct kinematics, not just a nice picture that looks like a cartoon, but the actual force, torque, the actual angle, if you could get everything right,
Yep.
that way, now what you could do is do 1,000 iterations on the animated version,
Exactly.
save a ton of time, and actually have optimized processes everywhere. That's really where so it's just this natural extension that started back at the beginning with one logical step,
Right.
following every logical step there through, and now because the technology is available to do it today that wasn't available 30 years ago,
Right.
you can bring the chain all the way through.
I first got turned on to, I knew what digital twins were, but the first time I really appreciated how they were going to totally change manufacturing was actually here at IMTS in 2018. And I was in the FANUC booth upstairs on the main floor, and they had, you've probably seen this exhibit, it is a FANUC paint robot that was simulating the painting of a Harley Davidson fuel tank, and so I spent most of my career in the coatings industry, in the plating and coatings industry, so that caught my attention right away. And in my last company, our largest customer was Harley Davidson, so I'm like, oh, this is really cool. So I stood there just captivated by this display, and an engineer from Fanuc came up behind me, and he's just kind of watching, and we started chatting, and he said, if you think this is cool, let me show you something else. And he took me across the aisle, and they had this little computer kind of in a corner, and he hit a couple things on the computer, and up comes a digital twin, an exact replica of what I was seeing on the other side. And you're exactly right. I would say the scariest day in the life of a manufacturing engineer is the day that you change the process, right?
Yeah,
I mean, everything's working, everything's good, and you're shipping parts, and somebody says, hey, we think we could do that better, and now we've got to figure out how to do it better. And then you go out to the floor and you change the process, and if it works, that was your job. And if it doesn't work, it's like somebody isn't getting parts, you're shutting down the line and so on. And now we can do all of that iteration digitally, or at least a vast majority of it, and it takes all the risk out of innovation. You think it's going to I think it will drastically advance the rate at which we can innovate in manufacturing?
Absolutely, and just deliver better products. So I used to build large automation systems. So we'd build a $5 or $10 million system.
Right.
And you got on your floor, you need to run it off, and then you need to tear it all down and ship it to the customer. Well, inevitably, the software guys get on the machine last because everyone's mechanically trying to get everything to go work. And so there's always a little bit of debug, a little bit of design stuff that has to go on. You got to modify a few things. Well, if you've got $10 million of equipment you need to leave there on your floor for an extra 2 months, that's a huge cost at the end of the day.
Right.
What you can do now, because everything, the pneumatic cylinders, the actual pallets moving through, the conveyors, the robots, all those things you can have in the digital twin. So we can actually take the machine and tear it down, and the controls engineer can keep working on the model, finishing, getting all the last debug, all the last programming, and then just show up at the customer's facility with the new complete software set, tested and proven.
Right.
Oh my God, what a time saver. And then just imagine that times a billion other ways that we have to normally take a lot of time, a lot of energy. Now you shorten up everything in that entire window.
Yeah, it shortens the entire window. It advances the rate at which we can innovate in technology and in manufacturing. And I think a lot of what we're seeing here this week at IMTS is a result of a lot of that digital design. We're really seeing here live the result of that. For our guests that are joining us on YouTube, you may have saw Doug wave a moment ago. We have had students coming by this booth all week long, so fired up about these careers in manufacturing. So that's what we were waving at, and they've just been absolutely fantastic. The energy here is really hard to believe. So let's talk now about those students and the education world in which they're spending their education time, in which they're being educated. So if we think about how quickly manufacturing is innovating, and that's been really the topic of our discussion so far, it really necessitates a rate of innovation in education that we haven't seen before either. If we're going to prepare these students for these awesome careers, we have to be educating them in different ways. Do you feel like, in as much as we're sitting here in the SmartForce Student Summit among all of these educators, are they starting to catch up, and will they be able to keep up with the rate of change in manufacturing?
Yeah, I think it's really been, unfortunately, slow to have happened the way we need to have it happen.
Right.
The practical reality is, I can remember when I was starting as an apprentice back when I was 15 years old, 16 years old, it was an issue then.
Right.
And it's been a while since I've been 15 years old. So, I mean, this has
has
been an issue for like 30, 40 years. But I think what's different now is what you see. I mean, Matt, to your point, what you see around you. The technology has become streamlined enough, it's become digital enough, it's easy to interface with, it's become portable enough, it's become much more bulletproof, so it's operational a lot longer, it's much, the reliability of these things, so the ability to interface with it, the UI, UX of the equipment, all those things are so much different now, so applying it to places where kids are going to learn is a little bit more seamless and easy now today to do it. So things like this, like a student summit, sure, it's great. They're going to get a taste of it, but then they got to go get it regularly.
Right.
But the other thing is, because robots are cool, robots are neat. Obviously, there's a lot of robotic things going on that get into the schools, and that's neat. All right, so we've got a little piece there that we didn't have a few decades ago. And so incrementally, yeah, I do see it happening. I think the other thing that you're starting to see educators do was they, normally just taking kids and streamlining them in one direction.
Sure.
And, manufacturing might not have been that direction. But as the educators are seeing the level of sophistication, the level of cleanliness, and just overall coolness in a lot of factories that would have been like, well, I don't want to But now you look at some of these places and you're going, this is a dream place to go look. It's like you're working at a Google lab in a kind of a manufacturing facility. This is the neatest thing ever. The whole dynamic has changed, and so I think there is the attraction for teachers and for student advisors to kind of get kids into that, and Manufacturing Day brings more kids into more facilities. They get to see it more, so I think there is more traction than we ever had before because Google and other people are doing drones and things like that, because autonomous vehicles are kind of this cool interfacing of technology and manufacturing and ways they see it every day with what they're touching. I think the glue is really starting to come together finally.
Yeah, I totally agree with you. And I think I've been in this business now, in the business of technical education, for 6-7 years. Like you, I spent a lot of time in manufacturing before I got over to this side of the world. And just what we've seen in the last 6 or 7 years in terms of the way our educators are looking at the need to get young people excited about careers in manufacturing, starting to understand that you can go direct to workforce right out of high school and have an amazing career if you want to. You can go to a technical college or even have an employer pay for your technical college degree. Or in the case of young people maybe pursuing a STEM degree, a 4-year degree at a university, go there with all of this hands-on experience and a context for what it is they're going to see when they get to the world of manufacturing. So I think it's a really, really exciting time for education, and I think we've grown in leaps and bounds in the last 5 or 6 years that I've been involved in this, and I just can't wait for the future.
Yeah, and the price of college university has also been a great thing, kind of helping us out. I went to Syracuse University back in the day.
Yeah.
I was fortunate to go on a full ride playing soccer.
Nice.
A lot of people don't get to do that, but still, that was maybe $2,500 a semester.
Yeah, I know.
I got a buddy sending his kids there. It's $75,000.
I know.
That's insanity.
Yeah, it's crazy.
$75,000 times 4 years. Are you kidding me?
I know.
That's $300,000. I got $300,000. That's $500,000 pre-tax.
Exactly.
And then if you have a general business degree, you got to go out and still go learn everything to go do something anyway. So the opportunity now with this being a tech-savvy career option for the kid that comes out and either just goes to, grab a 2-year community college or get hooked up with an apprenticeship program at a cool company that's doing neat things, and maybe go nights and grab that associate thing if you want to, and maybe go on if you want nights to a bachelor, don't do a bachelor. I mean, you can progress in this career if you have technical competency doing something.
Right.
You don't have to have necessarily a master's in something to own and run and build and innovate and create and be an entrepreneur, make your own company, or work your way up and be the vice president or president of something.
Right.
It happens now much more seamlessly than quote unquote 20, 30 years ago.
Right.
So it's nice to have an option, and not if you don't have $500,000 in your back pocket.
Right. Or you don't want to pay it back.
Yeah, you don't want to. Yeah, you don't have to. Exactly
career.
right.
Yeah, absolutely. So you think about one of my favorite examples is a young man named Kyle who graduated from a small high school in Wisconsin a couple of years ago. He took a 1-semester course in industrial robotics. So 1 semester, earned a certification. I know you're a huge fan of industrial certifications, as am I. And took a job the day after he graduated from high school with a manufacturing company, about $1 billion company, as a robot programmer. I don't know what he makes exactly, but that's a job that starts at $50,000, $60,000, $70,000 a year. You drive any vehicle you want. You've got all these options, and his employer will pay him to continue his education. And that's one of the things I love telling students is, look, if you decide to go in what's now become a non-traditional direction, which is something other than going to a 4-year university, it's not a life sentence. It's not something you're going to be stuck with for the rest of your life. You can make that decision, and it actually creates more options. It doesn't limit you, and it's just a great opportunity.
Yeah, no, absolutely, positively. One of the ways that's really been eye-opening for me in that, because I have always believed that. I'm always looking for examples of, hey, I know you believe that, but are you seeing it actually happening on the ground? We set up a tech center in San Francisco.
Okay.
So, and I'm out there a lot now, and recently we just integrated Silicon Valley robotics into AMT,
nice,
which is a really cool thing going out there. But you go out there, and I go into the incubation centers, the innovation centers, the startup centers, and what you're seeing is a lot of really sharp people that in many cases have dropped out of that 4-year university. They got together with some other cool kids, and they're going, I got a better way to build a mousetrap.
Yep.
And they get together, and they get into these labs, and they develop some stuff, and many of them are becoming really successful millionaires. And you talk to them about, well, how did you get here? What was your career path? What did you do? And, hey, I studied this. I was interested in math. I kind of like, but you know what? I just so wanted to go do something with my hands. Story after story after story. I mean, literally hundreds of examples I've met seeing it out there. And it happens everywhere.
It does.
But I'm saying the density there. There's tons of opportunities. You learn the base skill. get out there and do what you love, be passionate about it, you are going to find a great way to wealth.
Absolutely. That's exactly right. I was just reading a story in the Wall Street Journal this morning about this guy that dropped out of Brown University, actually, and started a software company. Just sold that company for, I think, $20 or $30 billion to Adobe, and that they're waiting for that deal to close. So it is just an example. In that case, you don't need a 4-year degree to be, certainly, and not everybody gets to be a 20 billionaire or whatever he is. But you're right. It's a great way to create wealth. You don't have this college debt as you're coming out of a 4-year university or beyond, and these jobs just pay incredible amounts of money for students starting out. And I love the point you made about you can become a president, you can become a CEO, you can own one of those companies. There aren't very many segments of our economy where you can start out at the ground floor and end up running or owning the organization, but manufacturing is still one of those places where that can happen. As we look around here at IMTS, I want to talk just a little bit more about all the great things that are happening. I want to give you a chance to take some credit for this amazing show. Here we are on day 5. It's hard to believe it's day 5 of IMTS already. Last day that we're broadcasting live here with the Tech Ed Podcast, and really appreciate you spending some time with us. But what are you hearing from attendees, from exhibitors, from, you mentioned the energy before, but go a little bit deeper on what you're hearing from the folks here.
Yeah, I mean, people were a little bit nervous. What's going to happen? Our show's coming back. Do people want to be here doing? And so there's always a little bit of that. I've always been very positive because I was the guy like you that came to the show looking for things I wanted to touch. I wanted to see. I'm not going to do it virtually.
Right.
And I'm not going to just go to one person's open house because I don't see all of the other things. So I felt that way, but until you get here, you're not sure, right?
Yep.
I got to tell you, this is beating everything we would have thought. Our numbers for visitors is the highest we've ever had for visitors. So
wow.
We keep track of, visitors, exhibitors,
Sure.
students, and international guests. And so some of those are a little bit lower than in 2018, which was our banner year, but visitors is the highest ever that we've had. So people are coming out, and when I talk to, so I've been walking around in between meetings, other things, which, unfortunately uses a lot of my time, but as I go around and see folks that I know, it's always the same thing.
Right.
The people who I know that are running booths that have equipment here are going, this is the best show we've ever been to. We exceeded our 2018 leads by middle of the week.
Wow.
And 2018 was the best
best
show ever.
show ever, right.
And when you say leads, they go, oh, but are they good though? Are you just getting? And they're like, no, we're qualifying people. These
Absolutely.
are high quality leads. And then when I walk around and see my buddies that ran shops, they're always like, hey, Doug, I'm walking down through the North Hall. Can you come visit? So all my old buddies, I'll try to go catch up to that own the shops and run the shops. And like, hey, what do you finally see? And they're going, this is awesome. We're looking for this. We're looking for this new multi-axis meter. We're looking for this type of Swiss. I'm looking for a robot to do this, that. All of them are going, I got everything I need here. We were buying stuff from the floor. I mean, the electricity on both sides of that equation. I mean, I've been coming to these since 1978.
Wow.
Right? My grandpa dragged me in 1978 to come here. This is the most electricity out of anyone I've been to, 22 shows.
That's incredible. Yeah, you've even got Greg Jones beat. I think he mentioned yesterday that he's at 18 now. So
yeah, his grandpa didn't drag him, I guess.
Right, exactly. Had to start him a little bit younger. But you make a couple great points there from the exhibitor standpoint. And in the business side of my life, separate from the Tech Ed Podcast, we do tons and tons of trade shows. And it's really, everybody wants to say, how many attendees. And it really isn't, attendees are important, right? But as an exhibitor, you don't really care how many people are there. You care how many quality people are there, how many people are really interested in your technology. And I've got to believe, given the focus of a show like this, that what you're hearing from the exhibitors you've talked to, we would hear from just about every one of them, is that, wow, almost everybody that walks by the booth is a potential partner, potential customer. So that part of it is really important. And I've talked to a number of job shop and OE machining people this week about what they're seeing and just what they're telling us about the technology and what they're telling us about the connectivity, the smart sensors, the smart devices. Lots of people talking about digital twins. We talked already about the fact that folks are finally settling into the idea that additive and subtractive, complement each other really, really well. As you've been around the show, Doug, this week, are there a couple of technologies, we've touched on a few of them, that really stood out to you? You talked about, the digital twins and so on, but what are some of the other things you've seen? Yeah,
I think over in metrology, that area doesn't get captured enough, and there's really interesting things happening there, especially because of that tie-in that you're just mentioning, Matt, about additive. You got to figure out new ways to measure things, and so there's things happening with CAT scan MRI technology that's actually been brought in now to metrology measurement to be able to see inside parts or see inside assemblies. That is super cool. Things that are happening with white light, blue light, to be able to, again, back to the digital twin. How do I get that over? If I don't have that drawing, if it's an older piece of equipment,
sure.
How do I start to integrate it in? bringing some of that technology in. So that's pretty neat what's happening over there. I think when you kind of going around to the rest of it, I haven't seen like this is that one technology that makes a difference. Sure. Again, it's, and you said it, it's this really the purveyance of a lot more integrated digital platform, digital technology, digital connectivity, making it really easy to interface with the equipment, to interface other devices with the equipment, to extract data and information, sure, and do things with it. It really gets to be important at the end of the day. We came up with MT Connect a long time ago, which is, without getting all complicated, it's a way for machinery and equipment and devices to communicate with a common language. Right. It's kind of like Rosetta Stone. It's a way to have kind of multiple different languages all brought to English, for example, and sure, then you can look at the English. The data coming from all these different pieces of equipment, in order for it to be usable, in order to do something with it, it has to be commonized. Speed has to be speed, force has to be force, torque has to be torque. You got to know what you're dealing with. And now things like MT Connect, with these things all being digital, you're seeing a lot more software companies here coming up with productivity tools, coming up with dashboards, coming up with ways to actually drive more efficiency out of your equipment because they figure out how to use machine learning, leveraging that data with an algorithm to accomplish the means to an end. That's cool.
Yeah, when we talk about digital transformation in manufacturing, when we talk about Industry 4.0, one of the questions I get most frequently from people in the manufacturing side, especially small to mid-sized manufacturers, is, we can't dedicate a full-time person to doing all this. How are we going to embed all this technology on our machine tools? And the answer is, guys, you don't have to do that. There are people that will do that for you. And as we look at more embedded smart technology on the machine tool builders are putting on their equipment, I mean, it's almost a ticket to the dance anymore. We've got to be able to pull speeds and feeds and what's the last part, what's the next part, what program am I running, what mode is my machining center in, all this information, just a couple of examples of data that we're pulling from machine tools. So they're doing it, and then to your point, now that we've got more common communication protocols and we can actually pull that data into and commonize it and measure it and use it in a common way. We had David Aguirre on here yesterday he's the IIoT technician at Gateway Technical College, talking about how he's got his Haas machining centers, his robo drills, his machining simulators, all of his robots, either flowing up to Fanuc MT-Link I or through OPC-UA, through a gateway to OPC-UA to MT-Link I. And so there are ways to do that, and it's a really exciting time for those smaller companies and small to mid-sized businesses because now they have access to this as well. You and I could talk about this, I think, all day long. I know you've got a tight schedule today. I do want to give you an opportunity to answer one last question, if you would. And it's a question we ask every single guest here on the Tech Ed Podcast, Doug, and that is, if you had one piece of advice for a high school sophomore, what's that piece of advice?
Wow. So my grandfather taught me something, or said something to me that I always just kept in mind. So his thing that he told me when I was a kid, he said, listen, Doug, success never surprises you. You got to keep on working for it. And it's one of those things where I just go, I took it kind of light when I was a kid, but what he was really saying is, hey, Doug, you do that little bit of extra push. You just open that one extra door. You just ask that one extra person when you're in a room, and it really pays huge dividends. And I always, even to today, I think about it. He was like, hey, Doug, if you just kind of do the ordinary, the extraordinary is not going to happen for you. So it just takes a little bit of pushing, a little bit of, there's a real by small example, we were doing an executive forum, there's a kid up there, came from RPI, and I was like, how did you find out about this? Oh, I was searching around looking at things that were happening at IMTS, and I saw this investor forum, thought to be really smart, interesting people there, and I go, well, how did you pay to get here? I talked the university people into sending me because if it was there a grant or something, because it would be really good and I could further my education, and he got here. Well, how did you get in? He go, well, I just started talking to people and figured out where you guys were and got in here. He met so many people up there. He's probably got 10 job offers only because he actually pushed to be more on the extraordinary side than ordinary. So success isn't going to surprise you. Just keep working for it.
And he didn't have to spend a penny of his own money to do it.
Absolutely right.
Found a way to do it with OPM, right? Other people's money, and it is. I mean, you can, if you're creative and if you've got that sense of perseverance and tenacity, it's amazing what you can accomplish in life. But you're right, it's success. I'm going to use that success. It wasn't going to surprise you. You got to work at it. Exactly right. Certainly, your success is no surprise, Doug, given all the incredible work that you're doing at AMT. We are at the SmartForce Student Summit powered by AMT this week, all week at the International Manufacturing Technology Show. Doug Woods, president of that great organization, thank you so much for being on.
Matt, thank you for being here and doing everything.